Okay, so welcome once again for Archicad Now for Engineer session. So we are in the fourth session of this webinar series. Earlier, during the first, second, and third session, we saw how to how to set up the project for creating structural BIM model in Archicad using the information that we receive from architectural team. And in the second session, we saw how to create the structural BIM model based on those architectural information, and also we saw how to generate the analytical model based on the structural BIM model, and then we saw how to export it and use it in different analytical model in third session, which was shown by Mr. Chidam. And in today's session, we are going to see the buildability score calculation for BCS standards, and also we are going to see IBS score calculation for Malaysian standards. And then we are also going to see how to calculate the concrete usage index. And then finally, we'll see how to document the layouts in Archicad and then publish them. Okay. So without any delay, let's get started. The first is buildability score based on BCS standards. So for today's demo, we are going to use Code of Practice on Buildability 2017 edition. And inside the buildability score in the COP for buildability, there are three components. The first is the structural system. So the buildability score based on the structural system, and the second one is the buildability score based on the wall system, and the final one is the buildability score based on DFMA technologies. For today's demo, since we are targeting on structural BIM modeling, so we are going to stick to structural system. So buildability score based on the structural system. So we'll go ahead and see the formula for it. The formula for buildability design score of structural system is 45 times the summation of ES into SS plus the structural buildable features points. So AS is the percentage of the area of a particular structural system inside the building model, inside the building. And SS will be the labor saving index that we can get from table 1 of COP for buildability 2017 edition. Okay, so we will see how to get this SS and how to compute this EAS, and then multiply it with, add all together for all the floors, and then multiply it by 45. So how to get this value for this particular term, and then we'll see how to get the values for structural buildable features points from the code based on different criteria that they have set. So for this buildable design score of structural system, the maximum point is capped at 45 here. Okay, I'll show you. So the maximum point is capped at 45, and for structural buildable feature points, the maximum point is capped at 5. There are actually more criterias. Even though if you are getting score more than 5 for structural buildable features points, it is always capped at 5. Okay. Okay, here is the labor saving index from the code of practice for buildability. So we have different structural systems here, like precast concrete system, structural steel system, cast in situ system, roof system. And for each system, we have different options like full precast or precast beam and precast slab only, precast column or wall only. So all this we have. So based on the option that the user chooses, labor saving index can be derived from this table. Okay, so this labor saving index, we have to create an expression inside Archicad, and we have to automate based on the option that the user chooses. Okay, so this I'm going to I'll show how the expression is created, and then during the demo, and how it is used during the demo. And after coming to the structural buildable feature points, there are different criteria, as I told. Some criteria is like, if you are using cast in situ concrete, it is mandatory to use welded mesh for more than 65% of your work. So this criteria is mandatory if you are using cast in situ concrete for floor. Okay, so and precast household shelters, if it is a residential non-landed property, this is also mandatory based on the percentage of coverage. Okay, and here we have standardization and repetition criteria. If you're using concrete columns and beams, this is also mandatory. You must have at least 3 most common sizes, and based on that, you can derive the criteria from this table. And if the story, if the typical story is more than 6, then these two criteria, 3A and 3B, are also to be considered for the buildable features points. And coming to this other structural buildable features like meter chambers, if you're using precast for meter chambers and MEP rises, you can consider these based on the percentage of coverage, like based on the extent in which you are using it in the project. Okay. And finally, we have if you're using high strength concrete, which is more than 70 grade, and then at least 5%, you can add 1 point to your buildability score. And if you're using self-compacting concrete more than 30%, then you can add two point to your buildability score. And then if you're using a diaphragm wall, 2 point. So these are the extra points that we can add. And if you compute all this, it should be always capped at 5. Okay. Okay, so here is how we are converting the labor saving index table to an Archicad expression. So we are using if statement inside here. So this option, right? So this labor saving index, we are converting this as an expression so that it is automated when the user chooses the option directly. So here we have structural system. So if it's an option set, later I'll show you during the demo. If the user chooses an option set, say for example precast only, then based on that value, the labor saving index will be automatically assigned to that particular slab. Okay. So here is how this expression is created. If you can, scan into this QR code, you can go to a article where you can find out how to use this logics. Here we are using IFS logic, where we can give the first logic condition here, and then if that condition is passed, you can set the value 1. Okay, and if it is not passed, if this condition is not passed, then it goes to the second condition, and then based on that it will give another value. Okay, so interpreting the table for labor saving index, if the user chooses the first full precast, then it is 1. Okay, so if the user chooses precast column or wall with flat plate and perimeter beams, beam depth less than or equal to 600 mm, then the labor saving index is 0.9. Okay, so in this way you need to add all the options inside your Archicad property manager, and then based on the option that the user chooses, we need to create an expression to automate this labor saving index calculation. So in this way, like all the options here should be added to the expression here. So here if you see, this is the expression inside which all the criteria have been considered. Okay. But in real case, say for example, so in real case, say for example, if you have a project which is having just full precast, you need not add the other criteria. So you can simply add one criteria and then still use this 1.1, and the expression becomes very simple. Okay. Okay, so again, now after creating the expression for labor saving index, now we need to compute the buildability score based on the formula that we have. So the formula we have is 45 times the summation of EAS into SS. So for that, EAS is the extent of area which that particular slab is having a system, the structural system, divided by the total area. So that is EAS, that is here. So and after that, SS is the labor saving index that we got from the previous that we got from here. Okay, so the previous property. So we are multiplying 45 times by that, and then dividing the top surface area of that particular slab by the total area, and this total area is put inside the project info here. So inside the project info, any user can key in the total area from the schedules. All this I'll show during the demo, how we can set up the project info and use that information inside the project manager, the property manager, to compute this buildability score. And finally, buildability score and schedule will be something like this for each story. Depending on the system that is chosen, we will have the area, and based on that area, we will have a labor saving index for the system, and then this will be multiplied and then we'll get multiplied, and we multiplied with this ratio, top surface area divided by the total area, and then multiplying it by 45, we get this buildability score system, which is this um, property. Okay, so and then finally we'll have another schedule where we will have the structural buildable features points. So that is based on the extra points that is met with these criterias. Okay. Okay, so now having seen the BCS standard, now we'll see the CIDB standard for calculating the IBS score, which is the industrialized building score, industrialized building system score. Sorry. So for that, it is almost same as that of BCA standard. Just the coefficients of terms differs. Okay, so here instead of 45 in the BCA score, they are using 50 here, and then almost the formula is same, and they are not having any extra features points that is added to the buildability, that is added to the IBS score. It's just the simply one term used here. But yeah, so this is the formula: 50 times the summation of QS by QST into FS. QS by QST is the percentage of area, exactly the same as what we computed during the BCA standards. And then FS is the IBS factor, which is similar to the labor saving index. Yeah, so this is the table from where we will get the IBS factor. Earlier during the BCA standards, we were having one dimensional table, meaning based on one option the user chooses, the value will be we'll be getting the labor saving index. But here the user will be choosing two options. One is for beams and columns, that is shown horizontally here, and the other is for slab. So the condition for slab and the condition for beam will be chosen by the user. And then based on these two conditions, we need to come out with the IBS factor, corresponding IBS factor. So it's like two-dimensional factors, affecting the IBS factor. And then finally, we also have the roof system. Yeah, so we can, based on the roof that is used in the project, we can consider this also. Again, we have to create an expression in Archicad for IBS factor table also, just like the labor saving index. But since it is a two-dimensional table, we have a very big expression. But as I said earlier, if your project is not having all the criteria, say for example, if your project is just having one criteria from here and one criteria from here, you can create a very simple expression and then start using it. And if there are two from here and one from here, just two expression, like two conditions are enough inside your expression. Okay, so that is how this expression is created. Yeah, similar to what we saw in that, we are using same IFS condition, IFS loop, but the difference here is we have two logics to be checked before assigning a value to the IBS factor. Okay, so for that, checking the two conditions, we are using the AND statement. Yeah, so we are using the AND statement. So the table 2, if the slabs condition is precast column, precast concrete beam, just like this one, and the in the same table, columns and beams condition is precast columns and beams, then the value is 1. So it is checking the two conditions and then assigning a value. And then the second one is uh, the B here and then the 1 here. B is in situ concrete on permanent formwork, and then the precast columns and beams for which the value is 0.8. So in this way, we have to add all the conditions, and that is why it is a very big expression here. Okay, after computing the IBS factor, then we need to calculate the IBS score. So for that, we have the same similar formula, just like BCA, 50 times the area by total area into IBS factor. IBS factor we computed earlier, and then this area is assigned to that particular element. We can get that area divided by the total area. As I told earlier, we can save it inside the project info, and that area we can convert it to a number and then use it here for computations and multiply it by 50. Okay, and finally the schedules look something like this. for each story we can compute the IBS score, and then we can use it in the submissions. Okay, so now let's go to the demo. So first I'll show the BCS standard for calculating the buildability score. So first thing we have to do is we have to go to the options and property manager and create our properties and give them the values. So the first is structural system. So the user need to choose the structural system for each and every slab. Okay, so here we have all the options that we had on the table 1 of the code of practice for buildability 2017 edition. So we have all the options. The user can choose the condition based on their project. So once that is chosen, so we have the labor saving index, next one, inside which we have used the expression to compute the value. So let me just expand it. Yeah, so it is just an IFS logic, checking for the first and then assigning a value for that, and checking if that is false, then it will check for the other one and then assign the value based on that. So it loops inside and inside and inside until the last option is there. Okay, so this way we can create the expressions. But as I told earlier, if you're just using one system or two system, you can just have two loops inside here instead of having so many loops. On the other hand, you can also approach us, because since we have already created, we can easily export this expressions and all the properties as an XML and then pass it to you, so that you can just import it inside your project and then start using it. After finding out the labor saving index, we need to find out the buildability score for the structural system. So again, we are using the expression here. Top surface area divided by the total area, multiplied it by labor saving index, and totally multiplying it by 45 as per the formula given in the standard. So here the total area, you can see it is coming from the project info. So inside file, info, project info. So if I go down inside the site details, you can see the total area is entered manually. So how this information we got, I'll show you during the schedules, but just know that we are entering the value here. So any user, they can simply come here, and if anytime the area is changed, they can just enter it here. It will automatically change the other corresponding values by itself. Okay, so going back to the property manager. Yeah. So this top surface area is again coming from the slab itself. Okay, so any particular slab that is having this system, the system that is chosen in structural system, it will have the top surface area. So we are getting that and calculating this value. Okay, so having created all the properties, I'll show how to create the graphic overrides to represent the buildability score based on colors in our layout and in our 3D view. Okay, so for that, depending on the system that we have, yeah, let me go into one rule. So the first rule I have is this particular the first option. Okay, so if any user chooses this first option, the color will be red. So it is both in 2D and 3D, it will be red. Okay, so if I go down further and check each and every rule, so I'll go down one by one rule and then set the colors differently, so that you can visually identify which color based on the color that we can see, based on the score. Yeah. Okay, so this is how the graphic overrides are set. Buildability score, so we have to enter all the options here. Okay, so after that we need to go to schedules and we need to create the schedule. For us, I think I've already created the schedule, but I'll show you how to create it. Okay, inside this scheme settings, we just create a new schedule from here, and then we are considering only this slab. Okay, and then I have a criteria to consider the first story buildability score, because during the submissions we need to have uh, first story, second story individually in buildability score for individual floors, in the layout. So say for example, if I remove this, and then so I'm just giving a slab criteria, and inside that these are the information that I want to see inside my schedules. So the home story name I want to see, and also I want to see the top surface area, and then I want to have a summation of all the top surface area at the bottom, and then the structural system that the user has chosen for that particular slab, and the labor saving index based on this structural system that is automatically computed by our expression, and finally the buildability score for structural system. And I also want a calculation of total for the buildability score also. If I click OK, you can see in the schedule, yeah, for each and every floor. Okay, and we have a summation of all the area, total area here, and also we have the buildability score of 39.44, 39.33 here. So this is the total area that the user will be entering here. Okay, so inside the project info, under the site details, the total area is 2515.95. So this is where the user will get this information and put it inside for computing the buildability score later. Yeah. Okay. So the user, if you can see here, all the slabs are having the same, same structural system. And if I go to the story here, let me just remove this. So this is the first story, and I'll show the build up, use the graphic overrides of buildability score. You can see all are in green color. If I go to the schedules, okay, I think it got changed. Yeah, so let me go here. If I change the option here, say for example, if I make it full precast for one of the slabs and then go to my 2D, you can see it got changed. It became red. Okay, similarly in 3D also, when I apply the buildability score over graphic overrides, you can see all are in green color except one which I changed just now. Okay, so if I want to change one more, say if I change this to maybe precast slab only, and then go back here, you can change the outer slab got changed to gray color. Okay, so let me change one more here. You can also change it inside the slab directly, going to the properties and classifications, and then inside that you'll have the properties assigned to that particular slab, and from there also you can change. Maybe I choose one of these, greater than, yeah, so it became yellow in color. Okay, so this way we can visually represent the buildability score for different slabs like this. I mean the structural system that is used by these stairs, I mean these slabs. Okay, yeah, so here we have seen all the buildability score for the structural system. Now we have another schedule for the features points. Okay, so the features points, as I showed in the slides, there were many criterias, but for this project, I'm just considering three criterias, which are the usage of welded mesh and the high strength concrete usage, self-compacted concrete. Okay, for that, I need to enter the percentage of usage. So again, I'm using the info, project info here to let the user enter the values here. So the user will enter the value here, high strength concrete usage, self-compacted concrete percentage, and then the percentage of welded mesh usage. So based on this criteria, again, I'll have an expression inside my property manager. See, so I have the, based on the criteria that we have inside the standards, we can, create the expressions like this. Okay, so for each criteria. Yeah, and then I have an addition of all this. As I told earlier, if it is more than 5, I cap it as 5. Okay, if it is more than 5 here, I cap it as 5. If not, I just use the same value. So going back to the schedules, you can see my first criteria is 0, and the second criteria is 1, and the third criteria is 2. So the addition of these two is 3. So now you can use this information inside your layouts. So for that, let me go to the layout, and let me go to the first story. And then you can see, as I have changed just now the values, the building system for this structural system for these slabs, it automatically changes the color both in 3D and in 2D. So now I wanted to add a table of buildability score just for the first story. For that, I have to get that information from the schedules. So now it is for all stories to just set the criteria only for the first story. I'm adding the home story option here, and then choose it to first story. You can choose any story that you want. Since I'm going to use it for first story just now, I'm just setting it to first story and click OK. So you'll get only the value for first story. Okay, so having seen that, you can just save this as an Excel file, and just go to file, save as. Let me save it inside desktop ds demo. Currently it is empty, so I'll save it as an Excel file and then click save. Okay, so let me go here. Inside that, just now it got saved. Opening it. Yeah, so we got all the information required. So let me just resize the columns and columns and rows. Yeah, so I can add the colors here. So based on the color that we have set here. So going back here, there are like 3 colors. Okay. Okay, precast full is red in color, and then the precast beam, these two are green in color. And then this one is gray in color, and the final one is in yellow. Okay, I guess this color. Okay, so I can copy this, just select everything and then click Control C, and then go back to Archicad, go to your layout where you want to paste it, and then click Control V, and then use a single figure and paste. So you can see your buildability score for story 1 here. And after placing it, you can sorry, yeah, let me place it first, and then I need to select it and then resize it. So yeah, if you want to make this smaller, just choose this and then reduce the size so that you can make this bigger so that it's more readable. Yeah, so this way you can set your layout with the 2D, 3D, and then the table with the color coding. Okay, so if you want for the second story, just go back to the here and then change the criteria to story 2 and click OK. So you'll get this. So you can save this as an Excel and then copy and paste it here inside your Archicad, inside the layout. Okay, so having created the layout, we will see how to do the concrete usage index, and then we'll see how to publish these layouts. For that, I'm just going to use a different model because The model currently we are using is always having structural, means steel as the beams and columns. So we want something with concrete. We are using this model, and if you see in this model, the stories 0, 1, 2, 3, 4, or the bottom stories, and after that from 5th to 20th it is typical story, and then we have roof which is on the top. So we need to calculate the concrete usage index based on this model, and this model is currently not having the substructure, but if in case you have substructure, we need to neglect the concrete usage of the substructure. Yeah, so in this model, since we don't have, we are not considering that. So again, for that we need to use the property manager. um, yeah, so inside the property manager, I think we just need to have only one, the story name. So because we are using the story name as a criteria, and then based on that story name, we are categorizing the components and their volumes inside the schedules. So any story, let me open this. So any story below the below 5th story, that is the story number 4, will have their own story name. Any story between the 5th story and the 20th story will have the story name as typical story, and the roof story, any story above that, will have their own home story name. So this is the criteria. So based on this criteria, we are going to categorize them and then calculate the concrete usage index. Okay, so this is the only expression that we need for calculating the concrete usage index. And inside the file project info, we need to set two parameters. One is the typical floor number starting and the typical floor number ending. So based on this value, the previous expression that I showed will assign the name to the stories. Okay, so having assigned the names to the stories, we can go to the core volume. We are going to calculate the core volume and the constructed floor area individually. So first let us see how to calculate the core volume. Yeah, so let me go to the scheme settings first. So here we are considering wall, roof, slab, beam, column, and we are neglecting the beam segment and column segment because it will be already considered inside the beam. So we'll get the volume from there already. So we don't want to get it again. So for that, we are neglecting that. And again, if you come in the end, we have a building material ID contains core. So this one I need to explain. I'll go to options, building materials. Inside the building material, for concrete usage index, we just need only the volume of the core. We don't want the volume of the finishes. So for that, what are all the building materials that you're going to use for core, we are putting a tag there as in the ID. So in the ID, just put core. Okay, so using this criteria, we are using inside the scheme settings here, and then filtering only the core, and then we are finding the volume of that particular building materials, that particular skins or components volume. Okay, so again here the story name is the story name that we created using the expression. Say for example, if it is between 4 and if it is between 5 and 19, it is um, what do we call it? It is called typical floor. Others are just the name of by itself. Okay, so just click OK, and you will see the first, second, third and fourth as the volume, and the typical stories, these are like from 5th to 20th story, and then finally we have roof. Okay, so addition of all this will be the volume, total volume of this project, which is just the volume of core. Okay, so only for that we are using this criteria here, and then we should name or we should add this core to our ID, building material ID, to just get that value. And after that we need to create another schedule called constructed floor area. Okay, so I'm using the scheme settings here. Using the scheme settings, we are just getting the slab and stars area. Okay, so here there's no much difference. We are still using the same story name that we created inside the property manager, and then the area of these components, and then adding all that when it is in the typical floor or in the different floors. Okay, and then having all the area. We have individually calculated both, so we need to save it as an Excel. So maybe I will just put it inside the same folder. And again, I need to save the core volume. So we are going to combine it in Excel and then find the concrete usage index. Excel and then save. Okay, so let me open the core volume and then the floor area. Okay, so for the floor area, I just need these values. Let me transfer it inside here. Sorry. Okay. Yeah, so I need to add all this. So it's sum of all this till this. Yeah. So in order to find the concrete usage index, it is volume by area. So for that, I need to just remove the value here, which is equal to the volume divided by the total constructed area. So it is 0.28. So this is the concrete usage index. And if you want it by floor, you can use the same criteria and then have before floor by floor. Okay, so with this you can put it inside your layout and do the submission for your green mark. Okay, so we saw how to do the how to calculate the concrete usage index. Now we'll see how to publish our layouts. So as I told earlier, it is just drag and drop or just copy and paste. So if you want any view from here, just drag and drop that view here, and then you can change the size, customize it. And if you want to publish those layouts, you need to go to the organizer and then create your own publisher sets. So for that, go to show organizer option from project chooser icon here. Yeah, so you need to create your own layouts for that. Say for example, if I create a layout here, a publisher set, just layouts, I just name it as layout BS and then create. So inside that you can see there is nothing. And if you want to just add the stories that you want, so just go to that folder and then click add shortcut. Okay, so earlier I was having first and second story, so here you can see we have two things. Okay, so just close it, and if you go back to here in the navigator, go to publisher set, and you can choose this publishing properties. Choose your layout that you created and then go to the publishing properties, and then you can choose the values here. Here I just want to save the files in the real folder structure, and then I will give the file location. Maybe I'll just give the same BS demo and click OK. And then I'll just publish. Okay, so both got published. Let me go to that folder. Inside the folder structure, we have two layouts that got published. So let me bring it here. Yeah, So these are the layouts that got published. One more is this one. I did not place the buildability score there, so it's not there. So yeah, that's all for today. Any doubts? Let me go back to the slides. Yeah, so these are the social media handles that we have. So please follow us. If you have any doubts or if you want our service, just please contact us through any medium. And we also have a YouTube channel where we post all these webinars once it is done. So you can later check out if you have missed any of the sessions. You can later check it out and get benefited. And we give training courses for basic, advanced, and advanced modeling and advanced documentation. So go to this link and then you can register for the training and get benefited. Yeah. So Q&A.
Very good, Vimal. So,
Thank you.
yeah. Any questions from the audience? Yeah.
Hi, hi Nazri here.
Hi.
Thanks for your presentation. I just wanted to clarify one thing. Previously, you showed that it's possible to filter by stories. But if let's say my model consists of 2 residential blocks, is there a way to only calculate the B score of individual blocks?
It is possible maybe by the name, but it's possible only by the name. If you
So normally what we do is when we have multiple blocks, we use hotlink module. So you can filter by the hotlink module's source ID. So then you can actually get the individual blocks B score.
Sorry, could you explain a bit about this hotlink module?
Okay,
Thanks.
hotlink module is actually like when you have multiple blocks, each block is created as an individual Archicad file, and you can do a link to the main file where you have all the blocks are assembled in. So when you select it, you can select the entire block as one, but when you get the data out of it, you can still get the data as for individual elements like slabs, walls, and so on. So we can actually use that concept so that you can isolate the information by block. So maybe I can share with you a link on the chat so you can try it out more. So what is hotlink and all those things, I will share a link on the chat. Yeah.
Okay, yeah, Ken, thank you.
Yeah. Okay.
Chidam, I have a question.
Yes.
From an architect point of view, normally when the architects design the building, right, we will do a composite slab with the finishes, right? Now, when this model is shared with an engineer will develop, say the structural slab itself. Of course, they will develop without the finishes.
Yep.
So in the normal process, of course, it will be best is later on that we will combine or federate it, the shared hot link into structure into our model. Does it mean that we have to remodel our composite slab to put in the finishes? That means we have to modify our. That means we have to detach the structural composite and just put in the finishes.
Yeah, thanks, Gary, for this question. It's really a very good one. Basically, for earlier session, if you remember, we might have shown 2 concepts. One is federated model approach. The other one is integrated model approach. So if you are, say, for example, both you and your engineer, both of you are using Archicad, then you can opt for integrated model approach, where the model is shared in a BIM cloud. Your engineer can join that, and they can switch off the finishes and show only the core of the load-bearing elements, where they can do the documentation, all these calculations, what we show today and everything. and they don't really create another model per se. So the federation and coordination doesn't happen in a way. But what if the engineer is using another platform, right? So then, of course, you need to go for a federated approach. They can get the reference from your model using IFC, and they can create a federated model. And when it comes to you, so you still have to link it and do a reference and update your model according to the changes the engineers have done. So that's why for us is if you go for integrated model approach, both you and your engineer use Archicad, then less work on coordination, right? So otherwise, yes, you had to link it and then update the model again and all those things you had to do it.
I see. So from day one, you have to establish that.
Yeah. That's the reason why we have this Archicad Now session to reach out to the engineers as well. So yeah, when you do that, you have really you save time on your coordination. Actually, we have seen this in some of our projects. So that's why we want to bring it to more people.
All right. Any references to this workflow? Please share with us if you can. Thank you.
Sure. I can get some material maybe next week's session. I will ask Vimal to share a bit more material on this focusing, right? So we will share it on the next week's session. Yeah, this workflow. So any other questions? Let me find a link for the hot link workflow first.
For materials, building materials, right? In Archicad now, because there's no basic standards of how the building materials, should be set up lah. So in this case, like say for the purpose of quantification, which reference in terms of setting up the building materials, so everybody have the same understanding what building materials are classified. For example, like say in this case structure, we will have a foundation, we will have a ground floor slab or ground floor beams, then we have an upper slab, upper beam. So normally these are the QS conventions. Are there any sort of conventions whereby we can actually adopt?
Okay, Archicad comes with the classification manager, and it has its own classification inside. It applies to the material as well. You can use that to, you can call it anyway, or the name, right? But if you use the classification, that is the standard, and you can apply this classification to the materials as well. So yeah, then that way is like instead of telling you are using concrete 20, grade 25 or grade 50 or whatever, instead of saying that, you can actually say, yeah, you are using this classification, right? So then it is a standard. Everybody uses the same classification. So that works, and Archicad supports that.
Yeah. Because like I say, the naming of some of these materials are not standards being used in the industry. One QS may want to call this concrete, but of course, one thing they have in common, for example, for beam, for example, beam, they will actually in the BQ they will classify, like say ground beam will be ground beam. Anything above ground beam will be considered as upper beam. Then we'll call it upper first, upper second, and so forth, right? But of course, upper beam construction can be probably grouped as one type of concrete beam, and the ground floor beam is classified as another type of concrete beam lah. For the purpose of BQ quantification, that's how they separate them. So my question is that, whether Singapore has a specific, or rather Singapore QS has a specific way of doing it or not?
No, actually, another thing is we can't get this information from the QS that much because this is kind of like a secret, belongs to them. They don't reveal much detail on how much they do it, right? So, but yeah, if you use the classification, we can whatever standards they internally use, the classification can be public, right? So everybody use the same classification.
Okay, all right. Anyway,
Yeah.
thanks.
Okay, so I'm sharing a link on the Hotlink Help Center article on the Hotlink. So just now to reply to the question, so you can check that out, right?
Thanks, Jim.
Yeah. Any other questions? Actually, Gary's questions are very good, actually. So going into the details of like, yeah, how the industry practice. It is true, like, yeah, when it comes to structural, you go by different floor, and the costing will be different also. Like, it depends on the story the elements are in. So you can actually combine multiple parameters of the element so that you can identify them even more. That's another option. So when we do the schedule, you can go story by story. So the costing can be evaluated differently.
In Malaysia,
Also,
there is actually a new standard measurement SKMM 3 which I'm trying to get hold of. So
okay.
if I'm able to get hold of it and understand it, then I will try to share with you guys.
Sure, thank you. That will be very helpful for us. Yeah. That is called SMM4, is it?
I think it's SKMM 3, not 4. 3.
SKMM3. SKMM3.
Yeah.
Okay. Okay.